Today, I will talk about arc length. The method we use to calculate the arc length is the integration. I will share with you all how the formula comes. We want to determine the continuous functions y, or we can call it fx, in the interval between a and b. So the distance between a and b here got a lot of small points here. Every very small point between each other have a very single small script. The smaller the script here, we'll call delta x. The more accurate to find the length of the curve. When we enlarge it, every single strip will become like that. So here we will call delta x. Got change of the arc length. And here we will call it delta x. And here we will call delta y. Okay. Length of the curve we can call sum of the p 0.1, 0.2 minus 0.1 and plus 0.3 minus 0.2. Then we would get it from like, here is 0.1, 0.2, then we add all, then we will get the length of the curve. So total we can write like that. The sum of the arc length, the formula is like that. Okay. Based on the Pythagoras theorem, we will write ds square equal to dx square plus dy square. Okay. So dx is equal to square root dx square plus dy square. After that, we time 1 over dx both. Then here will become dx over dx, and here we can let it like that, dx square root over dx square. So we will get the formula like that. So the formula after that will become like that. 1 plus dy over dx square. So in the arc length, in the formula of arc length, we will use x to replace it, or L. Just now we proved the formula already, but now we changed into the integration form. But in this integration form, we have two conditions necessary for this arc length formula. Every function in the point must exist. dy dx must exist. If dy dx fail to exist, then we need to change it to dx dy. dx dy may exist in the case we may be able to find the curve length to express the x as the function of the y and apply the follow in the equation. Second, the second condition is it has to be a definite integral with definite limit. For example, in the integration form must have the a and the b. Now I will show some example of the arc length questions. So based on this question, find the length of the curve of the function from x equal to 0 to x to 2. So first, we find the dy dx of this function. So the dy dx is 2 So we will get the answer is 1/3. Then we will get this answer. But in this question, it is undefined when the x equal to 0, because based on this graph, the curve is like that. So between 0 and 2, the x equal to 0 does not exist. Or we also can say the point x equal to 0 is filled to exist 2. Okay. So now so the point is undefined, or we can say is filled. Therefore, we can rewrite the equation to express x in terms of y. Y equal to x over 2. Then the equation will be like, after rewrite, the equation will be like that. And the range will change to y equal to 0 to y equal to 1. So we find the dx dy. So the dy dx now is continuous between the interval from 0 to 1. Therefore, we can start to find our arc length. So the arc length is between 0 to 1. The formula of the arc length is dy dx here square. So from dx dy is 3y1/2. Then we straight away do it. After we take out the bracket, then we will find the answer is y over. The answer will become 1 plus 9y over dy. So we want to integrate it. So make it simple. So we will make it in the bracket again. So it's like that, because 1 power of anything, and 1 power of anything also is a 1. So we can make it in 1 is 1 or power of 1/2. So now we let 1 plus 9y equal to u. So we find the du over dy will equal to 9. So here is dy. So we must find dy is equal to du over 9. So put in here. So it will become 1. Sorry, I make a mistake. So it's like that. 1 plus 9y is equal to u. dy is equal to du over 9. So we can take the 1 over 9 out. Then u power of 1 over 2 over du. Then now we can straight away continue to do it. We integrate it. It will become u power of 3 over 2 over between 1 and 0. After that, we want to simplify it and put the u inside again. So the 2 over 3 can take away. Then will become u over 3 over, so it's 3 over 2 between 1 and 0. So 1 over 9, 2 over 3, then we put in the u. Just now the u is 1 plus 9y. So 1 plus 9y power of 2 over 3 between 1 and 0. So we simplify it. It will become 2 over 27, and it will plus 1, 9 over 1, power of 3 over 2 minus 1 plus 9 over 0, then 3 over 2. So after simplify it, we will get the answer 10 power of 3 over 2 minus 1. Okay, now we continue to do it, then we will get the answer 10 power of 3 minus 1. So the answer is almost 2.27 is the arc length. Now I will show the second example for you. The second example, the question is find the arc length of the y equal to long bracket secant x, and the range is, the interval is between 0 and pi over 4. So based on this formula, the dy dx is exit, and it has the two conditions necessary of the arc length formula. It has to be definite interval with the definite limit. So the range, the interval is given, so also fulfill these two conditions. So let me start to do it. So first we find the dy dx first. So y equal to ln secant x. So let u equal to secant x. So du over dx is equal to secant x times tangent x. So y equal to ln u. dy over du is equal to 1 over u. So dy over dx is equal to dy over du times du over dx. So dy dx is equal to dy over du is 1 over u times du over dx is secant x times tangent x, and the u is the secant x. So we can substitute it. So the dy dx is equal to tangent x. So now we will use the arc length formula. The formula is in integration. The range is between 0 and pi over 4. Square root 1 plus dy over dx squared. The dy dx is tangent x. So let we integrate it first. Now, based on 1 plus tangent x squared, based on trigonometry formula, the 1 plus tangent square x is equal to secant square x. So we can change it to replace it by the secant x squared. So now pi over 4 0 square root secant x squared. So the power of the square root is power of 1 over 2. So 1 over 2 times 2 will become equal to 1. Will become secant x. So integrate pi over 4 0, it will become secant x dx. Oh, sorry, here I forget to write the dx here. Okay, now we continue it. The integration of secant is ln modulus secant x plus tangent x modulus pi over 4 0. So now the ln secant pi over 4 plus tangent pi over 4 minus ln secant 0 plus tangent 0. So the answer will be ln pi over 2 plus 1 minus ln 1 plus 0. So ln 1 straight away the answer is equal to 0. So the answer is ln square root 2 plus 1. Now I will show you the last question. This question is quite straightforward because the function is after differentiate, we need to find the normal or original function, then we need to use the integration. So we straight away will get the dy dx of the function. So we no need to find a dy dx again because it is given in the question already. So we straight away find the arc length. So the range is between pi over 4 minus pi over 4 to pi over 4. Okay. So secant 4 minus 1 plus square root square over d t. Okay. Now we will continue to do it. So substitute it, here will become 1 plus secant power of 4 minus 1 square root dt. And after that, plus 1 minus 1 will become 0. So we will left secant power of 4. Then power of square root, the power is 1 over 2 times 4 will become 2. So pi over 4 integration. Then here will become secant square t over dt. After integrate it, we can straight away get it tangent t dt. Okay. tangent t, no need to write 3t. So the range is pi over 4, 3t minus pi over 4. Then tangent pi over 4 is equal to 1 minus tangent negative pi over 4 is minus 1. So straight away get the answer is 2.